China's BYD just became the best-selling car manufacturer in the world by volume, and that milestone sent a very clear message to Tokyo. So how does Toyota respond to a rival building millions of vehicles a year with aggressive pricing and rapidly evolving technology? Not with flashier screens or bigger batteries. Toyota's answer has always been mechanical durability, engines that are engineered to outlast the vehicle around them. While BYD's rise is built on vertical integration, battery innovation, and speed to market, it's still a relatively young automaker whose long-term engine and powertrain durability simply hasn't been tested over the 15 to 20-year timelines that define real-world reliability. Toyota, on the other hand, has 3 engines currently in production or recent production that have already proven, through millions of real miles on real roads, that they can run past 300,000 miles with basic maintenance and nothing more. In this video, we are breaking down exactly which 3 engines these are, what's inside them that makes them last, and why Toyota is betting its entire reputation on mechanical simplicity in an era where every other manufacturer is chasing complexity. Let's start with engine number 1, the Toyota 1NZ FE, along with its later refined version, the 2NZ FE. This is the small 4-cylinder engine that has powered the Corolla, the Yaris, and various Scion models across multiple continents for over 2 decades. On paper, it does not look impressive. It is a modest 1.5-liter engine producing around 105 horsepower, nothing that would ever win a drag race. But horsepower was never the point. This engine was designed by Toyota engineers with one priority above all else: mechanical longevity through reduced internal stress. The 1NZ FE uses a lightweight aluminum block combined with a timing chain instead of a timing belt, which matters enormously for long-term ownership. A timing belt is a rubber component that wears out and requires replacement, typically every 60,000 to 100,000 miles. And if it snaps on an interference engine, it can destroy the valves and pistons in an instant. Toyota engineered the 1NZ FE with a timing chain instead, a metal chain that is designed to last the entire life of the engine under normal conditions, removing one of the most common causes of catastrophic engine failure in other manufacturers' vehicles entirely. The 1NZ FE also uses Toyota's VVTi variable valve timing system, which adjusts when the intake valves open and close based on engine speed and load. This does 2 things simultaneously. It improves fuel efficiency by optimizing airflow at different RPM ranges, and it reduces internal wear by keeping the engine operating in its most efficient combustion zone as often as possible. Less wasted fuel and cleaner combustion translates directly into less carbon buildup on the piston rings and cylinder walls over hundreds of thousands of miles. Fleet operators, taxi companies, and rideshare drivers across Asia, Europe, and North America have documented 1NZ FE-powered Corollas, crossing 300,000 and even 400,000 miles with nothing more than routine oil changes, timing chain guide inspections, and standard maintenance. That kind of track record is not a marketing claim. It's an accumulated data set built from millions of taxi fleets in cities where these cars run 12 to 16 hours a day, 7 days a week, for over a decade. BYD's smaller displacement engines used in its plug-in hybrid lineup, by comparison, have only been in mass production and widespread real-world use for a handful of years, meaning There simply is not a comparable multi-decade mileage record to point to yet, for better or worse. Engine number 2 on this list is the Toyota 2GR-FE, the naturally aspirated 3.5-liter V6 found under the hood of the Camry, the Highlander, the Tacoma, the RAV4, and even certain Lexus models depending on the generation. This engine represents a completely different engineering philosophy than the small economical one, NZ-FE, because it was built to handle real load, towing, highway passing power, and years of daily commuter abuse, all while maintaining the same reputation for outlasting the vehicle it is installed in. The 2GR-FE uses an aluminum block and aluminum cylinder heads with a dual overhead camshaft design and Toyota's dual VVTi system, which controls valve timing on both the intake and exhaust camshafts independently. This dual control allows the engine to fine-tune combustion timing far more precisely than a single VVT system can, improving both power delivery and long-term internal wear characteristics across a wider range of driving conditions. What really separates the 2GR-FE in terms of long-term durability is the strength of its bottom end, specifically the crankshaft and connecting rod bearings. Toyota engineers oversized the main bearing journals on this engine relative to its displacement, which reduces the load per square inch placed on each bearing surface during normal operation. Less stress per bearing surface directly translates into slower wear rates over the life of the engine, which is a big part of why independent mechanics and Toyota technicians alike frequently report 2GR-FE engines surpassing 250,000 to 300,000 miles with original internal components still intact, assuming the timing chain, water pump, and standard wear items have been properly maintained along the way. Toyota also uses a timing chain rather than a belt on this engine as well, continuing the same philosophy found in the smaller 1NZ-FE, removing a scheduled maintenance item that, if neglected, causes total engine failure on many competing vehicles. This matters directly in the context of BYD, because BYD's larger vehicles, including its SUVs and its higher-end sedans under the Denza and Yangwang sub-brands, increasingly lean on either fully electric powertrains or plug-in hybrid systems paired with smaller turbocharged gasoline engines, rather than a large, naturally aspirated V6 like the 2GR-FE. Turbocharging adds power and efficiency benefits, but it also introduces additional heat and additional moving parts. The turbocharger's own bearings, the wastegate, the intercooler plumbing, all of which represent additional points of potential failure over a very long ownership period compared to a simpler, naturally aspirated design. Toyota's approach with the 2GR-FE has always prioritized proven simplicity over outright peak efficiency numbers, and that trade-off is exactly why it keeps showing up in high-mileage vehicle surveys and independent reliability studies as one of the most dependable V6 engines ever mass-produced. If you made it this far, then consider liking this video, giving it a thumbs up, and subscribing to my channel. This helps me bring you more honest car advice. Engine number 3, and arguably the most important one in this comparison, because it is Toyota's most modern answer to the pressure BYD is putting on the entire industry, is the A25A FKS, part of Toyota's Dynamic Force engine family. This is the 2.5-liter four-cylinder found in the current generation Camry, RAV4, and Highlander, and critically, it is the gasoline engine paired with Toyota's hybrid system in the RAV4 Hybrid, Camry Hybrid, and Highlander Hybrid. This engine represents Toyota's direct response to the efficiency and technology race that BYD has forced onto the entire global auto industry. Because unlike the older 1NZ FE and 2GR FE, the dynamic force engine was specifically engineered from a blank sheet to hit thermal efficiency numbers that rival or exceed hybrid systems coming out of China, while still retaining the mechanical simplicity that has defined Toyota reliability for decades. The A25 AFKS achieves a thermal efficiency rating of up to roughly 41% in its hybrid application, a genuinely impressive figure for a mass-production gasoline engine, achieved through a very high compression ratio, a long-stroke design, and an advanced fuel injection system that uses both direct injection and port injection working together. Direct injection sprays fuel straight into the combustion chamber under high pressure for precise control and improved power, while port injection sprays fuel into the intake port before the valve, which helps keep the intake valves clean over time by preventing carbon deposits from building up on them, a problem that has plagued many other direct injection-only engines from competing manufacturers. This dual injection system is a quiet piece of engineering that most owners never think about, but it's a major reason why dynamic force engines are already showing lower long-term carbon buildup in oil analysis and borescope inspections compared to engines using direct injection alone. Toyota also engineered this engine with a variable control system for the water pump and an electronically controlled thermostat, both of which allow the engine to reach and maintain its ideal operating temperature more precisely and more quickly than older mechanical systems allowed. Faster, more precise warm-up means less time spent running in a less efficient, higher wear cold state, which compounds over hundreds of thousands of miles into meaningfully less internal wear. Combined with the dynamic force engine's use of a timing chain and Toyota's continued dual VVTi system inherited and refined from earlier engines like the 2GR FE, the A25 AFKS was clearly engineered with the same long-term durability philosophy. Toyota has followed for generations, just applied to a modern efficiency target that didn't exist when the 1NZ FE was originally designed. This is really the heart of Toyota's answer to BYD. BYD has moved incredibly fast by focusing heavily on battery technology, specifically its blade battery design, and on plug-in hybrid systems under its DMI badge that can deliver genuinely impressive fuel economy figures in short-trip city driving. That's a real, legitimate engineering achievement, and nobody serious in the industry denies that BYD has pushed battery chemistry and hybrid efficiency forward at a pace that surprised most legacy automakers. But Toyota's counter-argument, built directly into engines like the A25 AFKS, is that efficiency numbers on a spec sheet mean very little if the underlying mechanical hardware hasn't been proven to survive a decade or two of real ownership. Toyota's hybrid system, called Toyota Hybrid System, or THS, has been continuously refined since the first-generation Prius launched in Japan in the late 1990s, giving Toyota over 25 years of accumulated real-world data on how its hybrid batteries, its power split devices, and its gasoline engines age together as a complete system. BYD's DMI system, while impressive on paper and clearly effective in the market, has only existed in its current form since around 2021, meaning the oldest DMI vehicles on the road today are only a few years old, nowhere near the multi-decade track record Toyota can point to with its hybrid powertrains. None of this means BYD's engineering is bad, or that Toyota is automatically superior in every measurable way. BYD's rapid rise to the top of global sales charts happened because the company solved real problems for real customers, offering strong value, quick-charging plug-in hybrid options, and aggressive pricing that legacy automakers struggled to match. But when it comes specifically to the question this video set out to answer, which engines can be trusted to outlast the vehicle they're bolted into with only routine maintenance, Toyota's three engines here represent a body of evidence that simply doesn't exist yet for any BYD powertrain, because that evidence takes decades to build, not years. There's also a supply chain and engineering philosophy difference worth mentioning, because it explains why Toyota keeps making this same bet generation after generation. Toyota's engine designs, going all the way back through the 1NZ FE and 2GR FE families, deliberately avoid unnecessary complexity. Fewer sensors that can fail, fewer electronically controlled components that require a dealership scan tool to diagnose, and fewer moving parts overall that can wear out or break. This is a conscious trade-off. It sometimes means Toyota engines look less exciting on a spec sheet, slightly lower peak horsepower numbers, slightly less cutting-edge technology compared to what a company moving as fast as BYD can put out. But that conservative approach to engineering is exactly why independent long-term reliability surveys, fleet operator data, and high-mileage vehicle databases continue to show Toyota engines, especially these three, among the vehicles most likely to cross 200,000, 300,000, and even 400,000 miles without a major engine rebuild. The bigger picture here is that Toyota isn't trying to out-innovate BYD on every single metric simultaneously. Toyota is making a very specific, very deliberate bet that in a global market increasingly crowded with unproven new technology, there will always be a large and loyal customer base that values a vehicle they can depend on for 15 or 20 years without gambling on how well brand new battery chemistry or brand new hybrid architecture ages over time. The 1NZ FE proved that philosophy in compact economy cars for over 2 decades. The 2GR FE proved it in mid-size and full-size vehicles, carrying real loads for nearly as long. And the A25A FKS is currently proving that Toyota can bring that same philosophy into the modern hybrid efficiency race, without abandoning the mechanical simplicity that built the brand's reputation in the first place. So when people ask whether Toyota can actually compete with a company moving as fast as BYD, the honest answer is that Toyota isn't trying to win the same race. BYD is racing on innovation speed and upfront value. Toyota is racing on something that takes far longer to earn and far longer to fake. A multi-decade track record of engines that keep running long after the rest of the car around them has worn out. These three engines, the 1NZ FE, the 2GR FE, and the A25A FKS, are Toyota's clearest statement yet that mechanical durability, not just efficiency numbers on a spec sheet, is still the deciding factor for millions of drivers deciding which car to trust with the next decade of their life. If you are enjoying this video, consider watching this one where I am sharing the exact maintenance habits that let these Toyota engines reach 300,000 miles and beyond.